Welcome to my channel Munborimuk. Today we are going to discuss transportation problem with repetition of optimal solution. It means in the last class we discussed optimal solution of a problem which was solved by using Vogel's approximation method, and we got an initial basic feasible solution, and then we tested that initial basic feasible solution as optimal or not, and we found it optimal, but there we did not introduce a theta. And today we take another example where we can apply the introduction of theta. It means where we can apply the repetition procedure of taking u, I and vj. So this can also be taken as the repetition procedure of Modi method. Modi method is also it is the abbreviation of modified distribution method. Okay, today we discuss this problem with which with an intention to have a knowledge about the repetition procedure. So let us proceed with the problem. So this is the problem, and our question is solve the following transportation problem. Since question is solve the following transportation problem, we should understand and it should be optimal or not. We will verify optimality again, and if the solution is not optimal, then we find an optimal solution, and that will complete the solution procedure of the transportation problem. So this is the question. We are given here three destinations D1, D2, D3, and four origins O1, O2, O3, O4, and we are given the supply and demand. Supply and demand, as we all know, supply means the available items in origin 1, available items in origin 2, or available items in origin 3, available items in origin 4, which can be distributed to different destinations according to their demands. In destination 1, demand is 7. In destination 2, demand is 9. In destination 3, demand is 18. Total demand is 34. Total supply is also 34. Obviously, it is a balanced transportation problem. So let us proceed this problem, and to solve this problem, once again we will apply Vogel's approximation method. Some people may also call it Vogel's approximation method, VAM. So we apply VAM. Applying VAM, we first try to find out an initial basic feasible solution, and then we verify whether it is optimal or not. So let us proceed to the next slide. So here we will take the table again. This is the table. And so this is nothing but taken from the question. Then in the next table, we are going to form two more rows and columns. More rows and columns means one column will be penalty for different rows, and one row will be penalty for different columns. So these are penalties. Already we have obtained here penalties. In the last class we discussed how to obtain the penalties. Once again we will discuss here how to get the penalties. Penalties for origin 1, we see what is the minimum value of the minimum value of this minimum value of origin 1, 2, and second minimum value is 4. What is the difference between 2 and 4? Difference between this 2 and this 4 is 2. So we have got this 2. Then next one, we will see difference between the minimum two minimum values, 3 and 3, both are 3 max, then 1, 3 and 1. What is the minimum value? So 3 and what is the difference between 3 and 1? Difference between 3 and 1 is 2. Then next is, what is the minimum value in O3? O3 minimum value is 4, second minimum value is 5. What is the difference? These are the two minimum values, and what is the difference between these two minimum values? Difference between 5 and 4 is 1. Then next, origin 4, difference between 1 and 2, because 1 and 2 are the minimum values. Difference between 1 and 2 is again 1. So we have got these values. Similarly, we proceed for what? We proceed for different destinations. D1, what is the minimum value? 2 and 1. Difference between 2 and 1 is 1. So we have got this difference between 2 and 1 is 1. Yes, this is 1. Then this is 7. Then 3, 4. So the difference with this 3 and 4, we have to see the difference between 3 and 4 because they are the minimum costs. So lowest, the first minimum is 3, second minimum is 4. Difference between 4 and 3 is 1. So we have got here difference means penalty 1. Again 1 and 2, the penalty is 1. So what is the maximum penalty here, either row or column? So maximum penalty, we have seen there are two maximum penalties, 2 and 2. We, in that case, we can assume any one of these two. Suppose we take this shaded 2. Shaded 2 means we think for origin 1. And since we think for origin 1, therefore, let me rub this portion. Therefore, let me rub it first, and then, therefore, we have got what? We have to see what is the minimum cost in origin 1. In origin 1, minimum cost is 2. So let us drop down this origin 2 to our table. So we drop down this origin 2 to our table. It means this is the transportation cost for this cell, and transportation cost for this cell is this, and how many products can be, how many items can be distributed to this cell. It will be based on what? Will be based on the demand and the supply. In this cell, demand is 7, but supply availability is 5. So maximum 5 items can be distributed to this cell. Therefore, we distribute here 5 items. Once if we distribute 5 items out of all these 5, then this becomes this unit become empty. Means there will be no supply items. No, means it cannot supply any item further. So this portion becomes 0, and since 5 items are given to this cell, first cell, therefore, but it has a requirement of 7 items. So still there are 2 requirements. Yes, we have got 2 requirements. So first step we have finished, means we cannot distribute any item from origin 1. So we ignore origin 1 in our next slide. So after distributing these 5 items, therefore out of 34 items it becomes 29. Then we can proceed to the next slide. Next slide, ignoring 1, then ignoring origin 1, we write the other origins, so 2, 3, and 4. And these are the values. These values, and these are the supplies and demand accordingly. Then again, applying the same procedure, we obtain the penalties row wise and column wise. What is the penalty row wise? First row, penalty means difference between the 2 minimum costs. So 3 and 1, difference between 3 and 1 is 2. Then difference between 5 and 4 is 1. Difference between 1 and 2 is again 1. Again, difference between 1 and 2 is this difference between this 3 and 1 is 2. Then difference between 4 and 3 is 1. Difference between 2 and 1 is 1. So maximum penalty is these 2 and these 2, and we can take any one. Here we have assumed these 2, this shaded 2. So if we assume this shaded 2, then we have to think for origin 2. Origin 2. So what is the minimum cost here? Obviously, we think for the minimum cost. Minimum cost is 1. So we bring this minimum cost to the corresponding cell. Okay, let us bring it. Yes, once if we have brought it to the corresponding cell, then we are to supply as many requirements and as many availability, means maximum possible items we are to supply there. Maximum possible items means in this destination 3, total demand is 18, and in origin 2, total supply available item is 8. Means we can supply only 8, but we have 18 requirements, so we can give maximum 8 items to this sale. Okay, we give 8 items. After giving 8 items, then out of 18, 8 items will be will be already distributed, and these 8 items, all items are distributed. Therefore, this becomes 0, and this becomes 10. So this becomes 0 supply, no supply availability is there, but the requirement in destination 3 is again again left as 10. So we proceed to the next slide again. We proceed, and here the origin to no supply item is there. Therefore, we ignore origin 2. In our next slide, we have only origin 3 and origin 4. Then again the same procedure, we apply this penalty. So minimum cost here 5 and 4, penalty is 1, then 1 and 2, penalty is 1, then 5 and 1, penalty is 4, 4 and 6, penalty is 2, then 7 and 2, penalty is 5. Hope you understood how to obtain the penalty. That's why I am going a little bit faster. So we have understood how to get the penalties, and here we have seen 5 is the maximum penalty. Since 5 is the maximum penalty, therefore this time we think for destination 3, and what is the minimum cost in destination 3? Minimum cost in destination 3 is 2. So we put here put this 2 in the corresponding cell of this table. Here we have brought this 2 from the above table, and now we are to think how many possible items can be distributed to this cell. So in this cell, total available item is 14, requirement is 10. So we can distribute 10 items. After distributing 10 items, then this total requirement of 10 becomes 0, and out of this available item, out of these 14 available items in origin 4, 10 items have been supplied, therefore 4 items will still be there. Okay, this requirement of destination 3 becomes 0, and supply items available in origin 4 is still 4, means still some items are available there. So let us proceed to the next slide then. In this slide again, we ignore D3 now, and we take D1, D2 and O3, O4. Hope you understood why we ignore D3. That's why I did not explain it again. So applying the same procedure, we find the penalties. Penalties you understood. Penalties, the differences between the two minimum values. So here this penalty is 1, this penalty is 5, 4 and 2. Maximum penalty is 5. So and this penalty is in origin. There is a mistake. Or it should have been origin 4, and it should have been origin 3. So origin 3 and origin 4. Now, what is the difference between this? What is the minimum value in origin 4? Minimum cost in origin 4 is 1. So we drop down this 1. We bring this 1 to the corresponding cell. Okay, let us bring this 1 to the corresponding cell, and we now think how many possible items can be distributed to this cell. So we have a requirement of 2 in this cell, and we have supply item 4. So maximum 2 items can be distributed there. After supplying these 2 items, the total requirement of this destination becomes 0, and supply items will still be there as 2. Hope you understood. Out of 4 items we have supplied these 2 items here, therefore 2 items are still there. So let us proceed to after doing these things, we have 9 supply items available there, and 9 demands are available there, and our destination 1 has also been finished. Therefore we think for only destination 2. destination 2 and origin 2, origin 3 and origin 4. Okay, then uh, let me erase this portion first, this one. So then uh, we think for what? We think for only destination 2, origin 3 and origin 4 are there, and this is the cost for this cell, this is the cost for this cell. And here we think directly, nothing to find the penalty, we think directly what is the minimum cost. Minimum cost is 4 here. Since minimum cost is 4 here, we see what is the available item which can be supplied to this cell, and the available item is 7 and requirement is 9. Therefore only 7 items can be, maximum 7 items can be supplied to this cell. So in this table, maximum for this 4 we have taken here. Then we allot 7 items there, 7 items. After supplying 7 items, this total supply item in origin 3 becomes 0, and in destination 2 demand is still there. Demand, out of 9 demands we have supplied 7 demand, so there are 2 demands again available, and these 2 demands will go there because the supply item is also 2 and demand is 2, so that will go there, and that will go to 6. So we have, and our total requirement is finished, total supply item is also finished. Therefore these are zeros, and total this part becomes 0. Okay, then we go for the this this table means allocated sales, or we say evaluated sales, and these are evaluated sales. And we find the initial basic feasible solution. This 5 is in the this first row, first column. Therefore x11 is 5, then x2, this one x2, and x2, and this one is x2, and this one x2. Okay, let me take another color. This one is x2, x2 d3, x2 d3. Then this one x2 x2 d2, x2 d3. It means we write x22 is 7, x23 is 8, then x32 is 2, x33 is 10, and x41 is 2. So these are the values, and we get what? We get the cost. Transportation cost is what? As in the last class we discussed, what this cost is what? This a number of items supplied into the transportation cost. 5 is the number of items supplied to this cell, and 2 is the transportation cost per item. Therefore total cost will be 5 into 2. Here total cost will be 7 into 4. Here 8 into 1. So all are added here. Okay. After adding these things, then we have got total cost is rupees 80. So we have arrived at the initial basic feasible solution. Now we have to verify whether it is optimal or not. If it is optimal, it's okay. If it is not optimal, then we try to find out an optimal solution. So before that, let me erase this part. This one. Then let us proceed to the next slide. Yeah, this is the Modi method of optimality test, or we can say UV method. So this how to understand that there is a condition of optimality. First of all, we have to verify this step. M plus n minus 1 allocations are there or not. Then are these allocations in independent positions or not? And then we obtain Cij is equal to Ui plus Vj, and where Ui and Vj, these are obtained from the occupied cells or allocated cells, and then we find Dij, and this Dij is our main term. These Dij will help us to know whether the solution is optimal or not. Then let us proceed to the then and these are what if Dij, no Dij is negative, then the solution is optimal. If no Di is negative but one is zero, then so alternative solutions are there. Then if any one of the Dij's is negative, repeat the above steps and make plus minus theta to the cell evaluations in the corners in the loop of the largest negative cell evaluations. Calculate the value of theta by using the formula minimum value of cell evaluation minus theta, cell evaluation minus theta is equal to 0. Then reduce the value of theta from the respective cell evaluation. Okay, so we have got this thing. This part you can see from the slide by going slow motion, or you can use repetition, and you can see this slide. That's why I don't make any further delay. I proceed to the next step. Next step is, say, once again we have taken out the allocated cells from the last table. Then we see, we first verify whether m plus n minus 1, m plus n means how many rows are there? 1, 2, 3, 4. 4 rows are there. Then n means columns. How many columns are there? 3 columns are there. Then 4 plus 3 minus 1 is equal to 6 allocations. So exactly 6 allocations are there, and all of them are in independent positions. Since all of them are in independent positions, so first condition of optimality is satisfied. Therefore, we find what, as I already told you, we find UI and Vj from this table. So how to calculate or how to obtain UI or UI or Vj? In this case, first of all, we see the maximum number of allocations in any one of the rows. So here we have seen maximum number of allocations are in row number 4. So we take U4 is equal to 0 conveniently. We may assume some other values also, but more conveniently we assume U4 is equal to 0. So here we have assumed U4 equals to 0. If we assume U4 equals to 0, then U4 equals to 0, then we see we have written here C43. C43 means this cell. This C43 is just a minute. C43 is C43 is 10. C43 means U4 plus V3. U4 plus V3. So we have got this 10, U4 plus V3. So U4 plus V3, as we have assumed this U4 equals to 0, therefore V3 is equal to 2. This value, we for this, but we use the values written under written in parentheses. So these 2 will come here. We do not consider this 10. It means outside the bracket these values are not considered, but inside the bracket these values are considered. So we have got V3 U4 equals to 0, V3 equals to 2. So similarly, we think for the other values. So C42 is 6, and the U4 plus V2 is equal to 6. U4 is 0, so V2 is 6. Then we can have C23. C23 means this 3. So from this, yeah, I hope you understand now. C23 is C23. This one's C23. This C2, C3. This one is 1. C23 is 1 means U2 plus V3 is equal to 1. U2 V3 value is known 2, and U2 plus 2 is 1. Therefore, U2 is minus 1. Then we find what C41. C41 means this 1. U4 is 0, so V1 is equal to 1. Then we take what C11. C11 is U1 plus V1. This is 2. So the U1 plus V1, U1 plus V1, V1 already we have got 1, so U1 plus 1 is equal to 2, therefore U1 is equal to 1. Then C32, C32 means this 4, C32 is 4, so U3 plus V2 is equal to 4, U3 plus V2 is, the value of V2 is 6, so U3 plus 6 is equal to 4, so we have got U3 equals to minus 2. Now, we allocate these values in such a way, UI is in VJ table with cost evaluated cells. So these are the values. Just a minute, let me erase this. I think, yeah, let me erase this. This. So we have got this UI is a S bar. This is U1, U2, U3, U4, and this is V1, V2, V3, V3. So I think no need to this explain anymore. Then we can, and these values are the allocated values, evaluated values or allocated values, and these are allocated costs of the respective cells. And then we proceed for Cij for empty cells and Ui plus Vj for the empty cells. Empty cells, these are also called non-allocated cells, means these empty cells. There are some cells empty, and we think for these empty cells. So let us proceed to the next slide. And here we have taken this Cij matrix for empty cells. These are the allocated cost for the empty cells. And that's why these are written inside bracket, and these are the values for Ui plus Vj. Ui plus Vj, we have taken the chart again so that we can easily understand. Ui plus Vj, see, this position is U1 and this position U1 plus V2. U1 plus V2, what is U1 here? 1, V2 is 6. So 1 plus 6 is 7. And then next one is, this is U1 plus V3. So 1 plus 2, this is 3. Then this is minus 1 and 1. So minus 1 plus 1 is 0. Minus 1 plus 6 is 5. Then here minus this 0 plus 1 is this one, minus 2 plus 1. Minus 2 plus 1 is what? Minus 1. Then minus 2 plus 6 is this is not required, then minus 2 plus 2 is 0. So we have got this Cij for empty cells and Ui plus Vj matrix for this empty cells. Then our aim is to find out what Dij. Dij is what? This matrix minus this matrix. So let us find Dij. So 7 minus 7 is 0, 4 minus 3 is 1, then 3 minus 0 is 3, 3 minus 5 is minus 2, then 5 minus 1 is 6, and 7 minus 0 is 7. And here we have seen there is one negative value, minus 2 of Dij. So we have written here, since D22 is negative, so the solution is not optimal. And there is a 0 here. So since not optimal, therefore let us proceed to next step. Next step is what? We use plus minus theta in the cell. In the cell means in the loop, where say this is a loop. We have understood a loop has been formed by the allocated cells. So these evaluated cells, and these loops we put negative values for what? These two corners means maximum value we add theta, and the minimum value we add theta, and other twos we subtract theta. So we have got this, and we find what? We find, so this is the loop, and then we find what? We find this minimum, this 8 minus theta, 2 minus theta. Out of this 8 minus theta and 2 minus theta, which one is minimum? 2 minus theta is obviously minimum, so we take 2 minus theta is equal to 0. Then we get theta equals to 2. After getting theta equals to 2, then we subtract this 2 from the cell. So these are independent cells, nothing to do. And here the theta, we added theta here, so value of theta is 2, therefore we allocate here 2. Then here 8 minus theta, so 8 minus theta is 6, theta is 2, so 8 minus 2 is 6, then this there, nothing is done here, and 2 minus theta is already 0, so that part will be 0, not to write here. Then 2 plus theta means 10 plus theta, so 12, and this is 2. So we have arrived at this position now. We find again UI Vj by applying the same procedure. Hope you can find it out. This UI Vj here, which row has the maximum allocated cells? See, and there are two rows where similar number of allocations are there. Therefore, we assume this any one of these two, and U3, let us assume U3 equals to 0. U3 equals to 0, then U3 plus this V1 is equal to 1. And then 0 plus 1 is 1, so V1 is 1. Here we have got V1. We have got V1 is 1, then 0 plus 4, so this V2 is 4. Then here V2 is 4, and 1 plus this 1 means here 1 plus something is equal to 2, so this is 1. Then 4, 4 plus something is equal to 3, so 4 minus 1 is, so this is minus 1. Then 4 plus 0 is 0. Then here 1 and minus 1, this becomes what? This will be definitely 2. So we have got UI and Vj easily. Then after getting UI and Vj, again we have to follow the same procedure, Cij matrix for the empty cells, UI plus Vj matrix for empty cells in the new part. So these are values, and we can find out what this is. U1 V2, U1 V2, U1 is 1, V2 is 4, 1 plus 4. 1 plus 4 is 5, then U1 plus V3, 1 plus V3 is 1 plus V3. I think there is a mistake here. This 1 plus V3, this should have been, this should have been 3. V3, this is 3. No, this is 2. Okay, let me make it correct. Let me make it correct. This would have been 2. Let me take another color. This should have been 2. So this is 2. So 1 plus 2 is 3. Then this is U2 plus V1, minus 1 plus 1 is 0. Then this is U3 plus V1, 0 plus 1 is 1. Then U3 plus V3, 0 plus 2 is equal to 2. Then this is U4 plus V2, U4 plus V2, U4 plus V2, U4 plus V2, U4 it is 0. There is again a mistake, and this should have been 0. U4 is 0. So 0 plus 2, 0 plus 4 is 4. So we have arrived at this Cij matrix and Ui plus Vj matrix. Then we have to find Dij by applying what? This matrix minus this matrix. So we have got this 7 minus this 7 minus 5. 7 minus 5 is 2. 4 minus 3 is 1. 3 minus 0 is 3. 5 minus 1 is 4. 7 minus 2 is 5. And 6 minus 4 is 2. So none of the Dij is negative. Therefore, we can proceed to the next step. None of the so our solution is optimal, and this is the solution procedure. We have understood. This is let me erase this one again because it was for the previous slide. Let me have this one. Otherwise, it may disturb. So this is the optimal solution, and here we have got the optimal solution from the last table. Last table means last allocated table. So we have got the transportation cost is 76. So hope you have understood, and to know this, you please watch this class, this channel, this channel Moon Borimuk, and you please like it, share it, subscribe it, and then give a beautiful comment. So thank you again, and have a good day ahead.